Okay, welcome to our first unit here, where we're looking at solving linear equations. And what we need to remember is that a linear equation is one where the value of the highest power of our variable, say x, is 1. And when we're solving a linear equation, we are finding the value of that unknown variable. So first example, we have 3x plus 4 equals 16. And to solve a linear equation, it's really important, even just starting at the simplest ones, is to think, okay, what has happened to our variable x? And it's really important that we understand the order of operations. So when we look at that equation, we can see that x has first of all been multiplied by the 3. After that, the 4 has been added to it, and so that then equals the answer of 16. So if we want to work our way to finding x, what we do is we work our way backwards. We undo everything in the reverse order. So the first thing we need to do is to undo the plus 4, which means we subtract 4. And when we're subtracting 4, the rule is, when we're solving equations, is we do the same thing to both sides of the equal sign. So on the left-hand side, we subtract 4, and on the right-hand side, we subtract 4. Subtracting 4 on the left-hand side means that we now only have the 3x, because the plus 4 and the minus 4 eliminate each other. So we're left with 3x. On the right-hand side, we have 16 minus 4, which gives us 12. So now we have 3x equals 12. So a new equation in a sense. X is being multiplied by 3 to equal 12. And so we undo that operation, x times 3, which means we need to divide by 3. Doing that to both sides, x times 3 divided by 3 leaves us with just the x. And 12 divided by 3 gives us 4. So we can see our solution is x equals 4. With our second example, we've got 4x plus 3 equals 3x minus 5. Normally, the way I would approach this is to collect all my variables onto the one side, but the order doesn't really matter. So in this case, just to show you that the order doesn't matter as long as you're following the rules, I'm going to collect all my constant terms to the one side first. And because I want my variables on the left-hand side, I'm going to collect my constant terms to the right-hand side. So we can see that on the left we have plus 3, so that means we need to subtract 3 from both sides, leaving us with 4x on the left-hand side and 3x minus 8 on the right-hand side. The next thing we're going to do is now collect our variables onto the left-hand side. So I need to bring my 3x over to the other, and because the 3x is positive, I need to subtract 3x from both sides, leaving me then with x on the left-hand side and negative 8 on the right-hand side, and that's our solution, x equals negative 8. With this next example, we've got 3 outside of 2x plus 5 on the left-hand side of the equation, and that's equal to 27. Now what I'm going to do is show you two ways to do this. On the one hand, we're going to look at expanding the left-hand side as a first option. The second option will be, rather than expanding, to see that the 3 is being multiplied by that whole expression 2x plus 5, and which means that we could, as an alternative, divide both sides by 3 first. So we're going to look at both sides and see that they get the same answer. So expanding on the left-hand side, we've got 3 times 2x, which equals 6x, and then plus 3 5s are 15, and that's all equal to 27. And now we can see what we need to do is subtract 15 from both sides. So on the left-hand side, we're left with 6x, and on the right-hand side, we've got the 12. Okay. And now 6 times x on the left, so we're going to divide by 6 on the left and divide by 6 on the right. So we're left with x on the left is equal to 2, and that's our solution. So let's look at the second option. So we're starting with 3 outside of 2x plus 5 is equal to 27. And so we're going to undo the 3 times 2x plus 5 by dividing both sides by 3. So what we're left with on the left then is just the 2x plus 5. And on the right, 27 divided by 3 is 9. And now we can undo the plus 5, so we subtract 5 from both sides, and we're left with 2x on the left is equal to 4 on the right. And now we divide both sides by 2. So we're left with x on the left is equal to 2 on the right. And so we can see we have our solution. Let's now look at example 4. And we're now looking at algebraic fractions mixed with our equations. And in order to solve those where we've got more than one fraction with different denominators, what we need to do is, the first step in my mind is to get rid of the fractions. So what we need to do is multiply throughout the equation every term by the lowest common denominator. So we look at the denominators there, we've got 5 and we've got 3. So the lowest common multiple of those two numbers, so our lowest common denominator, will be 15. So what we do is we multiply each term, the x over 5, the 2, and the x over 3 by that lowest common denominator of 15. Now we simplify each of the terms. First of all, we've got the 15 and the 5 on the left. So 15 and the 5 cancel, leaving us with 3. The 2 times 15 gives us 30. And the 15 and the 3 on the right cancel, leaving us with 5. So now what we have is 3x minus 30 equals 5x. And now it's a simple equation. We're going to collect all of our terms, our variables onto the one side and our constant terms to the right. I'm going to keep my x positive, so I'm going to subtract 3x from both sides, leaving me with negative 30 on the left still and 2x on the right. Then just swap them over. So I've got 2x equals negative 30, and now dividing by 2, so I've got x equals negative 15, and that's my solution. So we'll take the same approach with the next example, and we can see by looking at that we've got a common denominator of 6, and so we need to multiply each of those terms by 6. So we can see 6 times the x minus 3 over 2, and then minus the 2x minus 4 over 3 is also going to be multiplied by the 6. And the 5 needs to be multiplied by the 6 as well. We mustn't forget every term gets multiplied by that 6. So now what we're going to do is we're going to see that the 6 can cancel with the 2, leaving us with 3. The 6 can cancel with the 3, leaving us with 2. Now we can expand the left-hand side, paying careful attention to negatives and positives. We're left with 3x minus 9, and then minus 4x plus 8 on the left-hand side, and that's equal to 30 on the right. And now we can collect our like terms. So we've got 3x minus 4x gives us negative x. Minus 1 equals 30. Add our 1, so we're left with negative x equals 31. And then x equals negative 31 as our solution. We can apply these same principles of solving equations to what we call literal equations or transposing formulas, where we have no numbers sometimes, but we have a combination of variables. And so we can see we've got this problem of ax plus b is equal to cx plus d, but what we need to do is solve it for x. In other words, we need to make x the subject of this equation. Okay, but what we need to think of is the other terms and variables we treat like numbers. The whole problem is solved in the same way. Now, because we're solving for x, we're going to collect all our x terms over to the left-hand side. So our cx on the right is positive, so we need to move it to the left. We're going to subtract cx from both sides. And when we do that, we're going to have on the left-hand side ax minus cx plus b, and then on the right-hand side, we'll be left with just d. And now we're going to move our b to the right-hand side. So we need to subtract b from both sides. So we're left with ax minus cx is equal to d minus b. Now what we need to do is take the x out as a factor. Okay, and when we do that, we're left with the brackets a minus c times x is equal to d minus b on the right, and now we can divide by the a minus c. So we have x equals d minus b over a minus c.